we need to go to our next presentation, and that is on also use of UHPC in conjunction with pneumatic spray application and robotic for repair and strengthening of culverts. That's a phase 1. Dr. Azizinamini is the PI working with Dr. Islam Mantawi as co-PI. I believe Dr. Mantawi is going to present this project. Dr. Mantawi.
Okay, so thank you everyone for attending the research day today, and thanks for the nice presentation before this presentation. As Dr. Merabi said, I'm going to be presenting the use of ultra-high performance concrete in conjunction with the pneumatic spray application and robotics for repair and strengthening of culvert, phase 1. Dr. Azizinamini is a PI on this project. I'm the co-PI in the shotcrete side of it. And Morgan Dickinson and Muhammad Fahim Afzal are both of them are PhD students working on this project. So I'm going to focus today on the shotcrete manually by manual operation, and the presentation after me will be by Anthony. He will highlight the robotics part of it. So the presentation today, I will start with introduction and motivation, why we are doing this research, project methodology, equipment and test setup or operation setup. And after that, I'm going to show a few videos, a couple of videos actually on a spray demonstration, and finishing with concluding remarks. So first of all, the overarching goal here, as you can see on this screen on the right side, in some cases we have a corrosion in steel pipes for culvert, and also some serious damage to a concrete culvert. So the overarching goal of this study is to repair deteriorated and damaged culvert. As much as we can, by some robotic advancement, we can reduce human intervention because it's very tight space in most cases, and also reduce traffic delays in the embankments. So in this methodology, we try to use spray application, or commercially named for it, shotcrete, using UHPC. You can see on the left side of the presentation, the culvert repair using other than the UHPC, using other materials, using spray application. We can use also spray application to build a new element for new construction or repair existing damaged or deteriorated column or bridge girders. So here is actually on the left side is the flow chart that we are using to develop the UHPC for shotcrete. So first of all, we have rheology investigation. And in this case, we use static and dynamic test, and we are concerned about material rebound or loss, bumpability, and also if the mix can be hindered by some durability issues. And after that, we have material investigation. We need to confirm that the compressive strength and motor elasticity, all those mechanical properties, didn't change much during the process. We do have also constructability investigation. We will need to know the removal of contaminated concrete, what shotcrete equipment suitable for the operation, surface roughness and preparation, as Dr. Azizi mentioned in the previous presentation, on some QA and QC methods. And application varies from bridge deck, overhang, or over or underlay, bridge piers for columns, and also steel and concrete culvert. So if I start with the static and dynamic flow test, here actually we are using some time interval to measure the change in the flow in the material, the UHPC, over time. So you can see here how much the static flow change over time. So every interval of 10 minutes, we are monitoring the open time of the material. Material rebound is very huge issue actually in shotcrete in general, because in regular concrete mixes, we do have large aggregate, and those large aggregate tend to hit even existing large aggregate or not a sufficient built mortar thickness, so that so the shooted materials tend to rebound. But since UHPC, we use very fine aggregates, there is no coarse aggregate, and it's kind of flowable, we have an opposite observation, which is the material dripping. So which is, both of them can translate, even material rebound or material dripping can translate to material loss at the end. Here actually related to material rebound, which is actually the how thickness we build up thickness. So can you see here we have some core taken from shooted material specimen, and you can see here in the most gray on the top how much, like a ½ inch build up in this specimen. We also conduct some bumpability testing, and you can see here the flow of the material. On this material was without fiber, but we were able to shoot it with fiber too. Also, surface preparation, as Dr. Azizi mentioned last presentation, sometimes we do sandblasting, but also in this project we use some different membrane skins with different amplitude of roughness to just measure different roughness conditions. So here is actually going to move to equipment and setup. This is a panorama video of the entire setup. So as you can see here, first we do have a UHPC mixer on the right side, and also we have a ground mixer which needed at the end to clean up the pump. We do have an air compressor that we rent every time we do the shot creating process. And also we have the pump, nozzle, and hose that connected to the air compressor. And on the left side, you can see two specimens. Those ones are like 60, one specimen actually 60 and two specimens, each one is 8 by 2, so a path of 16 feet long. Here's some, I'm going to show you some videos on the shot create process. We have a law student helping in this one. Hopefully, this is the first specimen I mentioned, and you can see there is the pump is single piston, so there's always pause and continuation of the shooting. But we were able to build up. If I want to make sure that we are shooting over the concrete substrate. And at the end, if I just move the video faster, you can see that we were able, the specimen was really on the ground, this one, in the beginning, and it was tough to reach the palm, but as you can see here, we were able to shoot the concrete or the UHPC with fiber. We did another trial with this specimen was lifted 2 feet above the ground, and if you can see here, we were able to shoot the material over this concrete substrate very nicely with fibers. There is a lot of detail that we will follow up in some publications and in future, but this material was using, we were using a ABC UTC mix with we reduced water to cement ratio in order to reduce the flowability. And if I just move to the end, we were able to complete like 3 complete passes of shooting of the UHPC for the specimen. And this is my concluding remark. I do believe I have a few minutes for question, actually more. This is the final product with more than 2 or 3 paths of shoot creating of the material. This is a like demonstration for demonstration purposes, and we will continue this project with some specimen construction through shot create and testing. I think I may have some questions.
Thank you very much, Dr. Mantawi. Yes, let me see. There's a question And I say very relevant to this, your last slide that you still have on the screen. It's asking how would you adjust the thickness for not flowing down or sagging?
You mean sagging by the material dripping?
Yes.
Okay, so there is a lot of details that we are trying to adjust the rheology of the material actually to make it buildable. But one technique was to after the first path, we tend to move the nozzle back to the pump and circulate it, wait for a few minutes so material to dry out, and do another path of shooting. So there is like always path between the paths, the shooting paths.
Thank you very much. Let me see another question. Asking, can you explain a little more about the mix for the pneumatic spray?
Yeah, the mix actually is the base mix is published under ABC UTC, which is the ABC UTC mix. But what we did is we changed the rheology to make it less flowable by reducing the water cementitious ratio, and so we play to reduce the flowability in order to build up the thickness. And more details you can access our website for the ABC UTC mix, UHPC mix.
Thank you, Dr. Mantawi. Another question coming up. If you want to give like 2 or 3 applications that most appropriate for this type of spraying, what would that be?
Yeah, it will be, as I mentioned earlier, the repair and retrofit of structures. So either by encasing, similar to the work that Dr. Azizi did in the UHPC shell, encasing the structural element with the UHPC through shotcrete instead of having formwork. The second one for sure, which is the title of the presentation, for culvert repair too.
Okay. There's one question I have, Dr. Mantawi. Do you think that having a kind of mesh or reinforcement, even fabric to hold the mix up there, would that be an option here?
We actually tried. I didn't present it today, but we faced some challenging using it too. So our objective was to use different roughness and see how it perform, and after that we may enhance the buildability of the thickness by other means of fabric or chicken wire or other material.
Okay, so you have in your plan to.
We actually tried, but we decided to go for just concrete substrate with different profile of roughness and sag blasting to make sure that at least we are going to be able to do it in the worst case scenario, which is without any help from wires or fabric to hold the material. But it is, yeah, it's a valuable, it's valid concept, yeah.
Yes, and continuing that question, I think you might have hinted during your presentation, but about overhead application.
Yes.
How is that going
to? You mean more details about it? We didn't try it in overhead application. We just tried for now on the 90-degree or like horizontal shooting instead of the vertical up shooting. It will be more challenging because the gravity will play a role for more tripping. But as I mentioned, as you adjust the rheology of the material and prepare the surface, you have better chance to succeed in shotcreting UHPC.
Okay, thank you very much, Dr. Mantawi.